Welcome to IronHand Tech. Every year, over 50 million tons of glass are produced worldwide, and most of it is used in the beverage and food industries. About 70% of the global glass production becomes waste after just one use, especially single-use bottles. In the US alone, more than 12.3 million tons of glass were discarded in 2018, and only about 3.1 million tons, or 25.3%, were recycled. Glass has an interesting feature. It's inert, meaning it doesn't react with whatever's inside it, and it also means it doesn't break down in landfills. It could take millions of years for glass bottles to degrade. The good news is that glass can be recycled infinitely without losing quality. Now let's explore this magical recycling process from start to finish. Like every great story, it starts with the basics. The materials. Used glass, mostly from bottles and jars, is collected from recycling centers or bins. This is the most important step, and it's something every one of us can contribute to: sorting waste. Once the glass is cleaned, it's crushed into small pieces called cullet. Cullet is the primary material for making new glass. Crushing the glass speeds up the melting process, saves energy, and makes the material easier to handle in the next steps. Screening machines help sort glass by size, with larger pieces being separated and crushed again for the recycling process. We still have bottle caps mixed in there, so our trusty magnetic separator steps in to remove any metal contaminants. This machine pulls the metals out of the mix and collects them in a separate bin, ready for recycling in another special process. Using cullet in production significantly reduces the need for raw materials and lowers the required melting temperature, saving energy and reducing CO2 emissions. About 1 ton of recycled glass saves up to 315 kilograms of CO2 and 40% energy compared to using new raw materials. The crushed glass is then sent to the dryer. The dryer helps remove moisture and lightweight contaminants like paper, plastic, and dust from the glass. Optical sorters help distinguish brown glass or ceramic fragments. If brown glass gets mixed into the production of clear or green glass, it can alter the color and lower the value of the final product. Even a tiny bit of brown glass can cause issues because it doesn't blend perfectly with clear or green glass. And as for ceramics, they don't melt at the temperature that regular glass does. After being sorted and cleaned, the glass moves to the crushing machine, where it is ground into fine powder, ready for the next step. The powdered glass is then mixed with other raw materials to create new glass. The raw materials include silica sand, about 50%, soda ash, and limestone. The ratio of these components can vary depending on the type of glass product being made. And now things really start to heat up. Literally, the furnace temperature is a whopping 1,600 degrees Celsius. If you're imagining a giant microwave, well, you're not far off. This is where our mix of sand and broken glass turns into something shiny and bubbling. We call it GOG, a strange but fun term to describe molten glass. Turning the furnace on and off consumes a lot of energy, so the furnace runs continuously 24/7. Glass was first discovered and used around 3,500 BCE in the ancient civilizations of Mesopotamia and Egypt. However, it wasn't really invented by humans. It was discovered by accident. There's a legend that glass was discovered when Phoenician merchants stopped by a beach and used limestone to build a cooking fire. The high heat melted the sand and limestone, accidentally creating glass. Around 50 BCE, the technique of glass blowing was invented in the Syro-Palestinian region, marking a significant milestone in the history of glass. By the 19th and 20th centuries, industrialization and the advent of recycling technology made glass a ubiquitous material, allowing faster and more efficient production. This development made glass a common, widely used product in everyday life. Now things start to get interesting. We're not just making glass. We're turning it into the perfect bottle that you can hold in your hand, take a sip of something cool and think, wow, how was this made? And right here, at this moment, molten glass is poured into a mold, air is blown in, and voila, a glass bottle is born. There are two methods to make this happen: blow and blow, or press and blow. The blow and blow method is used for narrow neck bottles like beer and wine bottles. First, the molten glass is cut into small sections and placed into a mold to form a preliminary shape called a parison. Then the parison is blown a second time to complete the bottle's shape. The press and blow method is often used for products with wider necks. Molten glass is pressed into a mold to create the initial shape, and then air is blown in to form the final shape of the bottle. But we're not done yet. You see, freshly blown glass can't immediately withstand the harshness of the outside world. It needs a little time to recover. Just like we need to rest after a stressful meeting, glass needs to cool down slowly. And now it's time for the all-important quality check. The finished glass bottles are inspected using automatic devices to detect defects like cracks, bubbles, or other flaws. These machines can spot the tiniest imperfections that the naked eye can't see. After inspection, glass bottles usually undergo surface treatment by applying a protective coating to increase durability and reduce friction during transportation. This helps minimize the risk of scratches or breakage during storage and shipping. And so, from those old shards of glass, from those bottles that seem to have reached the end of their journey, they have been reborn, ready to serve once more. Recycling isn't just about creating something new from the old. It's a journey of sustainability and responsibility, and it all starts with sorting waste, a small act that brings tremendous benefits. Welcome to IronHand Tech. Today we're embarking on a journey that you might not have expected. Every year, 30 million tons of wood waste are produced globally. And without efficient recycling processes, this wood would simply pile up in landfills, causing waste and pollution. But thanks to advanced recycling technologies, we can turn these discarded wood pieces into MDF boards, a material widely used in construction and furniture manufacturing. So, how do these old, ugly wood boards get transformed into brand new, shiny products? What's the secret behind this process? And what kind of machinery plays a role in this incredible transformation? Let's dive into the details. Wood waste comes from various sources: demolished construction sites, old furniture, or even wooden pallets. You might think this wood is only worth throwing away, but you'd be surprised to learn that it's actually the golden material for recycling. Once collected, the wood is transported to recycling facilities for the sorting process. On average, a large recycling plant can process up to 100 tons of wood waste daily, but only about 80% of it can be recycled. Careful sorting ensures that only the best quality wood is used in the next stages, saving time and energy during the MDF manufacturing process. The wood is fed into a large chipping machine, where it is shredded into small pieces. Large blocks of wood are quickly turned into a stream of wood chips, flowing continuously on conveyor belts. These chips are sent to a metal separator, where metal impurities are extracted by magnets. Eventually, we obtain wood chips. These wood chips are further ground down to produce wood fibers, which are then passed through a screening process where only wood fibers smaller than 0.5 millimeters are retained. The screening machine plays a crucial role in ensuring that the fibers meet the required specifications for MDF board production. The wood fibers are then cleaned, with all impurities removed, to prepare for the next stage. This is one of the most critical steps in the wood recycling process, determining the quality of the final product and the success of subsequent stages. A typical factory can process up to 10 tons of wood per day, and for every ton of recycled wood, we help reduce about 0.8 tons of CO2 emissions into the environment. For pallets, there's a special process before the wood is chipped. Robots separate the pallet boards by pulling apart the connected wood pieces, removing nails, and disassembling the pallet into wood planks in just seconds. At this stage, the wood has been shredded, but it still contains some moisture. If this moisture isn't removed, it could negatively affect the MDF manufacturing process and lead to mold in the future. Therefore, the wood must be dried to ensure the final product's durability and quality. This is where the drying machine comes into play, looking like a giant mobile oven. The wood chips are placed in a large rotary drum where hot air is blown in to remove the remaining moisture. The continuous rotation ensures that hot air can reach all the wood chips, ensuring even drying. The rotary drum dryer operates by rotating the drum containing the wood, while hot air is blown through. This machine can process 5 tons of wood chips per hour. The temperature inside the machine can reach 150 to 200 degrees Celsius, which is enough to dry the wood without burning or damaging it. The next step involves adding resin, a vital component in creating strong, durable MDF boards. Urea formaldehyde resin is the top choice because of its excellent adhesion properties, low cost, and water resistance. Modern mixers can mix tons of wood with resin in just a few minutes, ensuring that every fiber is evenly coated. This step determines the MDF board's strength, load-bearing capacity, and resistance to termites. A typical wood recycling plant uses around 500 tons of resin annually to produce MDF boards, with resin making up 8 to 10% of the final product's weight. Now it's time to transform these resin-coated wood fibers into finished MDF boards. This is done through hot pressing, where temperature and pressure are the key factors. In the massive hot press machine, layers of resin-coated wood fibers are stacked and pressed under extremely high temperatures, up to 200 degrees Celsius, and pressure, 30 megapascals. The boards are held under this pressure for 5 to 7 minutes until the resin fully binds the fibers and the board becomes solid. Each MDF board, after pressing, will have a thickness ranging from 6 to 25 millimeters, depending on production requirements. A large wood recycling plant can produce up to 100,000 MDF boards per month. Once the boards have been hot pressed and cooled, they need to be finished. This means cutting the boards to standard sizes and sanding the surfaces smooth. Industrial saws will cut the boards into standard dimensions, usually 1.2 meters by 2.4 meters for MDF or plywood. Modern cutting machines can handle multiple boards simultaneously, ensuring uniform size and maximizing productivity. After cutting, the boards are passed through a sanding machine. Sanding belts move across the surface of the board at high speed, removing any rough spots and creating a smooth surface. This is an essential step before the boards are used or finished with surface coatings. If you've ever sanded wood by hand, you'll know how tedious it is. But don't worry, these industrial sanding machines can do the work of hundreds of craftsmen in just a few minutes. We're almost done with the journey of the MDF board. But before it's ready for use, there's one final step to make it look sleek and attractive: surface finishing. MDF boards can be coated with a layer of melamine or thin wood veneer to create a decorative surface. This process enhances the aesthetics and protects the board surface from environmental damage, such as scratches or moisture. Surface finishing can increase the board's lifespan by up to 30% and produce a more visually appealing product. A large factory can finish the surfaces of thousands of boards daily with high precision. Every year, the world produces millions of tons of wood waste from construction, furniture, and industrial sectors. Without wood recycling plants, this wood waste would contribute to the growing global waste problem and deplete forest resources. According to statistics, recycling wood helps reduce CO2 emissions by about 30% compared to producing new wood boards. This significantly contributes to the fight against climate change and the protection of forest ecosystems worldwide. Every piece of wood, no matter how small, can be part of a sustainable future if we know how to utilize it. Recycling is not just about reusing materials, but it's also a symbol of innovation, creativity, and responsibility for future generations. We're not just recycling wood, we're recycling hope for a cleaner, greener future. Who would have thought that from discarded wood, we could create such sustainable products? And the best part is, if any MDF boards don't meet the standards, we can recycle them again. It's a cycle that never ends. Welcome to the IronHand Tech channel. Today we'll be diving into one of the most fascinating videos about plastic recycling. We are going to explore the process of turning plastic waste into oil. Yes, you heard that right. We can actually convert plastic into oil through pyrolysis technology. It's not magic, it's science. And theoretically, you could be using oil made from the very plastic bottles you've thrown away. Let's explore how scientists and engineers are changing the game by transforming one of the biggest environmental problems into a solution for the future. Get ready, because this journey is going to be exciting. First, let's talk about the name that sounds a bit complicated: pyrolysis. Pyrolysis, also known as thermal decomposition, is the process of breaking down organic compounds by heating them at high temperatures without oxygen. Imagine if oxygen were present, we'd have a massive fire. But because there's no oxygen, the plastic doesn't burn. Instead, it breaks down into smaller compounds, including oil, gas, and black carbon. Simply put, you're burning plastic to break it down into its basic components so they can be reused. If you think of burning plastic like burning a candle, then pyrolysis is like burning a candle in a vacuum. Don't worry, no need for spacesuits like in sci-fi movies, but this process is really cool. This process not only helps us solve the plastic waste problem, but also turns it into oil, a reusable resource. So how do we actually do this? Like any recycling process, the first step is collecting and sorting the plastic. While there are many different types of plastics, not all of them will produce the desired result during pyrolysis. Plastics like polyethylene, polypropylene, and polystyrene found in plastic bags, food wraps, food containers, bottle caps, and foam packaging are good candidates because they yield high oil recovery rates. On the other hand, PET plastics and PVC plastics produce less oil and release harmful gases. Once the plastic has been sorted, it's fed into a shredder. This machine chops the plastic into small pieces, usually between 2 to 5 centimeters, preparing it for the next stage. Think of shredding plastic like chopping up ingredients before cooking. You wouldn't cook a whole chunk of meat, right? When the plastic has been shredded and impurities removed, it needs to be dried because moisture in the plastic can reduce the effectiveness of the pyrolysis process. You don't want water mixing with your plastic oil, trust me. Now we move on to the heart of the process, pyrolysis. This is where the plastic is fed into the pyrolysis reactor. This reactor heats the plastic up to 900 degrees Celsius in an oxygen-free environment. At this temperature, the molecular bonds vibrate intensely, causing them to break apart into smaller molecules. The result? 80% oil, 15% gas, and 5% black carbon or ash. A rotary kiln is often used to ensure the plastic moves continuously inside the reactor, ensuring even heating. Imagine it as a rotating chicken roaster, but instead of roasting chicken, we're melting plastic. And here's where the magic happens. The plastic breaks down into smaller compounds like oil, hydrocarbon gas, and black carbon. After the plastic has been broken down into hydrocarbon gases, they are transferred to a condensation unit. Here, the gases are cooled and condensed into liquid oil, much like when you fill a glass with ice and water vapor condenses into droplets. In this case, those droplets are oil. These oil droplets can be used for heating, electricity generation, or even sold to refineries to produce diesel fuel for vehicles, tractors, and more. While pyrolysis technology holds great promise, not everything runs smoothly. There are several major challenges we face in this process. Plastics come in many different types, from polyethylene to polycarbonate. The cost of sorting and processing to obtain the right material for thermal decomposition can be quite high. Many plastics contain contaminants, such as heavy metals or dyes. If not handled properly, these substances can release harmful gases during the pyrolysis process. Pyrolysis technology is not limited to recycling plastic into oil. In the future, it could be enhanced to handle different types of waste and even help reduce carbon emissions from industries. Who knows, maybe one day we'll see cars running on oil made from the plastic you threw away yesterday. It would be amazing to see your waste powering the world. And that is the journey from plastic waste to oil through pyrolysis technology. It's a process that may not be simple, but it's incredibly important in solving today's environmental challenges. With this technology, we are not only recycling plastic, but also tapping into a new resource. Remember, every time you see a piece of plastic, it's not just waste. It could be oil, energy for the future. So let's recycle together and make this world a better place. The plastic bottles we use daily and the clothes we can't live without, these seemingly unrelated things share a special connection. That connection can help reduce the plastic waste destroying our planet. The water bottle you just threw away could become something fashionable and useful. More and more fashion brands like Adidas, Nike, and Shein are increasing the amount of polyester made from recycled plastic in their products. But how can plastic be turned into fabric? PET, polyethylene terephthalate, is one of the most common types of plastic used to make water bottles. It's lightweight, durable, and highly recyclable. Plastic bottles are stripped of their labels, caps, and glue. Then an optical sensor system takes over. This technology distinguishes PET plastic from other plastics, like HDPE, used for milk jugs, or PVC. This precise sorting is crucial because we need pure PET plastic for this process. But why PET? PET is suitable for fiber production thanks to its linear polymer structure, which is heat-resistant, hard to break, and retains its shape, making it ideal for producing durable fibers. Now, these plastic bottles will be ground into small pieces. This grinding process breaks the plastic into fragments measuring between 10 and 12 millimeters, known as flakes. These flakes are then placed in a water bath, where the heavier PET flakes sink to the bottom. Other plastic fragments float and are skimmed off the surface. The PET fragments go through multiple washes to remove any dirt or remaining glue, resulting in clean, pure PET flakes. Since they're wet, they are dried, causing the water to evaporate, leaving behind clear PET flakes. These clear flakes are then packaged, ready for the next step. These flakes will be melted in furnaces at temperatures reaching 260 degrees Celsius, along with color powder. This is the dope dyeing technique. Why is the temperature important? Because this temperature is high enough to melt the plastic, but not destroy the PET's molecular structure, allowing us to create strong fibers that retain the good qualities of plastic. The melted plastic is then pushed through tiny holes in a spinning machine, forming long, slender plastic fibers. This process is similar to how you might squeeze out pasta, but instead of dough, we're working with molten plastic. This spinning process requires precision. If spun too fast, the fibers could break. If spun too slowly, the fibers won't be thin enough to create the soft fabric we desire. It's a delicate balance, and modern machinery allows us to achieve it. Once the fibers emerge from the holes, they cool and gradually solidify. The spun plastic fibers are stretched into thin, yet incredibly strong strands. They are stretched using a series of rollers. This is the critical raw material for creating fabric. The fibers continue to be straightened and stretched by passing through additional machines. Several fibers are threaded through eyelets and lubricated to prevent them from sticking together. A series of drums stretch them to more than 4 times their original length. At the end of this process, we have primary fibers. The finished fibers are then cut into the desired lengths. These are called loose fibers, which are then sent to the spinning machine. Soon we have carded fibers. Workers attach these carded fibers to a machine that combines multiple strands, which are run through rollers at different speeds to stretch them out. The result is a compact, uniform thread, ideal for spinning. The fibers are twisted together and wound into spools for weaving. Chemically, PET and polyester are identical, giving this fabric the qualities of durability, heat resistance, ease of dyeing, and quick drying. Now these plastic fibers will be woven into fabric. The crosswise and lengthwise fibers are interlaced to form a sheet of fabric. Depending on the fabric's intended use, we can choose the appropriate weaving technique. For instance, plain weaving will create soft and lightweight fabric, while twill weaving results in stronger and more durable fabric. The fabric isn't ready for the market right after weaving. It must go through a finishing process, which includes checking for defects, trimming, and surface treatment. The fabric will be softened, excess fibers removed, and sometimes even coated with protective layers like water-resistant or wrinkle-resistant treatments. Every recycled plastic bottle not only reduces plastic waste, but also helps cut CO2 emissions, saving energy and water. A study shows that recycling 1 ton of PET plastic can save up to 7,000 liters of water and reduce 15 tons of CO2 emissions. Major brands like Adidas and Patagonia see the potential of recycling plastic into fabric. For instance, Adidas' Parley line of sneakers is made from recycled ocean plastic. In 2020, they produced over 15 million pairs of shoes from recycled plastic. Recycling plastic can solve the raw material problem while also being a sustainable solution for the future. Scientists are developing technology to recycle plastic multiple times without compromising quality. This opens up opportunities for plastic to become an endlessly renewable resource. Each time you sort your plastic bottles in the trash, you're contributing to a more sustainable supply chain, a world where plastic is no longer a problem, but a solution. From seemingly useless plastic bottles, we can turn them into sustainable and eco-friendly fashion. Every time you wear a recycled garment, you're helping to solve the plastic waste problem. Let's work together to make small changes for a cleaner, brighter future. Welcome back to IronHand Tech Channel. In the gut of this giant whale are more than 1,000 pieces of plastic waste. You heard right, more than 1,000. The haunting image of this whale is the clearest proof that plastic waste is increasingly affecting the marine ecosystem, requiring us to implement sustainable and effective measures to handle plastic waste. The most common method of disposing of plastic waste in many countries today is landfilling. Traditional plastic products take a very long time to decompose, from 100 to 1,000 years. Straws take 100 to 500 years, and plastic bags take about 500 to 1,000 years. Economically, plastic waste is no longer just a waste that needs to be disposed of, but a resource that needs to be exploited. In this video, we will explore one of the effective methods to improve the plastic waste problem, an exciting and hopeful journey, where things like plastic bags, plastic bottles, and food containers All the things we usually throw away can become strong building blocks. Let's get started right away. First, it is necessary to collect and classify plastic waste so that it can be produced into bricks. Plastic is classified by color and type. Not all types of plastic are suitable for making bricks. HDPE plastic, PP plastic, ABS plastic are types of plastic with high durability, good heat resistance, and easy to process. They are suitable to become the main material, while plastic bags are often used as additives, and PS plastic and foam boxes cannot be used to produce bricks. The plastic is removed from labels, dirt, and impurities before being crushed by a crusher. This increases the contact area, helping the plastic particles bond more tightly with other ingredients during the mixing process. After being crushed, the plastic will be mixed with some additives, such as sand, cement, or even ash from thermal power plants. This helps increase the durability of the brick. The ratio of ingredients will be carefully calculated to achieve the best results. From the mixed plastic mixture, we will put them into the extruder at a very high temperature, about 350 degrees Celsius. At this time, the molten mixture will blend together and be extruded out of the extruder. Now it is time to turn them into bricks. The hydraulic press is entrusted with this task. Under their pressure, the plastic mixture is pressed into bricks. The bricks after pressing will have standard shape and size. They are immediately cooled to gradually reduce the temperature of the brick to avoid cracking due to sudden expansion. Recycled bricks have the advantages of being lightweight, durable, strong, soundproof, heat-insulated, waterproof, and much cheaper than traditional bricks. Producing bricks from recycled plastic helps reduce the amount of plastic waste released into the environment, limiting pollution, building schools, houses, paving sidewalks, playgrounds. Recycled bricks are increasingly present in our lives. Plastic bricks replace traditional building materials, reduce the exploitation of natural resources, and protect the environment. The future of the construction industry is using these recycled materials. And who knows, maybe one day your house will be built from the plastic bottles you threw away today. Turning plastic waste into bricks is not only a waste treatment solution, but also an opportunity for us to build a greener, more sustainable future. Let's join hands in recycling so that discarded materials have a chance to be regenerated and help our lives. We only have one Earth. Let's act together today so that the bricks of the future will not only build houses, but also build a sustainable world for future generations, and we will never see another whale carrying a body full of plastic waste again. Thank you for watching the video. Let us know your thoughts in the comments below. Don't forget to hit the like and subscribe buttons to support the channel. For now, goodbye. See you in the next video.